Okay. You ready? Okay, using Normalcdf and inverse norm. What is that, right? Watch what it says. Use these when the values do not appear on the graph, right? That's very important. Or when you don't have a graph. That's another way of doing it. No graph provided. Or no graph on 16, right? Provided. No graph provided. I want you to highlight Normalcdf here with all the stuff that comes after it. And I want you to highlight inverse norm with all the stuff that comes after it. Let's go find these two functions. I tell you what to press to get there. If you press second and then vars, you should see a button. The button is vars. It's close to the arrows here, right there. I'm hovering next to clear. How's that? Clear? Second vars, you will see Normalcdf, right? And inverse norm. Those are the two that we're going to use. I just stick to these for now. Okay. So let's see what they do. We'll calculate the probability of data points existing between two values. The answer is given as a decimal. We multiply by 100 to get the percentage. Normalcdf needs 4 entries separated by commas, and here they are. Lower limit, upper limit. So you're saying I want to find out the percentage of families between $40,000 and $50,000, let's say. That's the upper and the lower. What's this? This is the mean, and this is the standard deviation. So you will give it upper and lower limit followed by mean and standard deviation, which you will be provided with. And these two you will also somehow be provided with, right? Lower limit is the value that would be to the left, right? Lower limit is to the left side of the curve. Upper limit is to the right side of the curve. Okay. Remember that if z-scores are given, remember this, folks, because a lot of times when I give a z-score, I don't give you a mean and a standard deviation. But the mean, like if you have z-scores, the mean is 0, right? Remember, if we're talking z-scores, the middle is 0, and the standard deviation is 1, because you're going up by 1. Automatically, if there's a z-score, this is true. Okay? It actually makes it a lot easier. What about the other one? Inverse norm. It needs the percentage of data below standard mean and standard deviation. We'll calculate the actual value along the x-axis we are looking for. So it could be the height, the weight, number of days, etc. Remember that. Can I just say this? This needs to be stated as a decimal. State as a decimal. That's very important. Otherwise, I won't know what to do. So remember this, folks. This is very important. This is brand new. Okay, if 35% of people earn more than $50,000 per year, then I want you to think of it this way. If 35 earn more, the whole curve from end to end, do this here. From end to end, what percentage is the whole curve? 100%. All of it. If you go from end to end, you would have to think of the whole curve comprises 100% of my data. So this would be 100 minus 35, which means 65%. 65% earn less. Okay, so if I tell you that 35 is on this side, earn more, right? Earn more, then 65% earn less. So it's almost like if it's a 10% chance of raining, then there's a 90% chance of it not raining, right? It's like a supplement. They supplement each other. On the other side here, if 42% of students spend less than 15 minutes on homework, then, okay, pay close attention to this. The 42 spend less than 15 minutes. This is your middle where you would have 50-50, right? If you put 15 minutes here, then half students would study less, half of the students would study more. So the 15-minute line should be somewhere in here. 15 minutes. And 42% would fall here. And on this side would be 100% minus 42. So that would be 58%. Study more. And 42% study less. Okay. So I always want you to think of, like, the percentages kind of tell you where along the x-axis the value is. And I also need you to know that both sides add up to 100% always. Okay? Remember that. Let's try. I want you to try something with me, okay? So just follow me back. We're going to go back a little bit in time before we start a potato chip question, which I'm probably not going to have enough time to start. So I'm just going to go back and let you practice here. So follow me, please. So let's say you want to know the percentage of males between 172 and 179.5 centimeters. We used our graph to answer that, right? 81.5. And I hate to tell you, it's a bit of a lie. This is a bit of an estimation. So how can we know exactly? We're going to do this on the side. So write this down right under your normal CDF. And we're going to go 172, comma, 179.5, comma, the average is 177, and the standard deviation is 2.5. Remember, lower, upper, mean, and standard deviation. Those are the 4 things that you need for this function. So let's say you're not there. So we're going to go second vars, call normal CDF, and then type that in 172, comma, 179.5, comma, 177, comma, 2.5. Close the bracket. And what do you get when you hit enter? You got to multiply that by 100. So we're going to times it by 100 to get percent. It's 81.85%, 81.86. And you're like, Mr. Dirksen, you told me it's 81.5. That is when we go by the graph and we're just estimating. This is exact. So we're going to put down 81.86%. Okay. Let's try one more before we go. The percentage of males expected to be taller than 182. Write this down first. Normal CDF. Lower is 182, right? What's my upper limit? Does it tell me an upper limit? No? No. So this is what you do, folks. Put a really big number in here. I like 10,000. A person that's 10,000 centimeters tall. You're just exaggerating because you're saying, I just want to make sure I get all the percentage of males that are taller than 182. So you decide this. If we were talking like how many people make more than $1 million, you would put $1 million here, and what would you put over here? $100 million or something really, really big, okay? But 10,000 most of the time for what we do does the trick. And the mean is still that, and standard deviation is 2.5. Plug that in and see what you get. Watch, yeah. That's it. Almost. Okay, 182, comma, 10,000, comma, 177, comma, 2.5. And I multiply that by 100. Mr. Dirksen was lying to us this whole time. It's an estimation, okay? And it's not off by that much, so we're not talking significant difference, right? Hold on. What if I had done this? Why did you use 10,000, Mr. Dirksen? What about if I just use 1,000? Because that's a really big number when it comes to these heights. If you round that, you still get 2.28, right? So it's not the end of the world. I would say just go big or go home, right? That's what I'm going to say. Hold on. I can't assign this for homework because I haven't done enough, okay? Can you just focus on this then at least? It's more of the stuff I seed you on today. And just focus on, this is the textbook, okay? So remember what it looks like? Some of you forgot what it looks like because you barely use it, right? It looks like this. Okay. And that's it for today, guys. Thank you.